Welcome to this explainer. Look, if you've been paying any attention to the tech world lately, you already know that artificial intelligence is moving at absolute breakneck speed. But, with that insane speed comes a really massive problem, and that is terminology. The overlapping jargon in the AI space has become completely tangled up. So today, we are going to definitively untangle that vocabulary. And how are we going to do it? By using a very human analogy to solve a totally digital problem. We're going to build a worker from the ground up, piece by piece, so you can see exactly how everything actually fits together. Right off the bat, we have to tackle the big one. Is a model the exact same thing as an agent? Well, lots of people, honestly, even seasoned tech professionals, use the words model and agent completely interchangeably. But today, we're going to see why that is a huge misunderstanding. Treating a model as an agent is basically like confusing a car's engine with the actual delivery driver. It completely limits how we build, deploy, and most importantly, secure these systems. Okay, to separate these conflated terms once and for all, we really need a foundational architecture. Taking a look at the system design defined in the Claude Code Integration Framework, we're going to break down this entire architecture and pin down exactly what words like model, agent, skill, and plugin actually mean in practice so you never accidentally mix them up again. So here is our quick roadmap for today. First, the core AI formula. Second, anatomy of an AI worker. Third, skills and plugins explained. And fourth, the proof, showing exactly why an agent does not equal a model. Let's get right into it. All right, kicking things off with Section 1, the core AI formula. It turns out the exact relationship here is actually a simple multiplication problem. An agent literally equals a model multiplied by a prompt multiplied by tools. Think of a specific large language model, something like Opus 4.8. That is your model. Then you have its instructions. That's the prompt. And finally, you have what it's actually allowed to do in the real world. Those are its tools. All three of those combined, that's what equals the agent. So the absolute most crucial point to take away from this is that the model itself is purely a reasoning engine. It's pure cognition and nothing else. Basically, a model is just a brain in a jar. An agent, on the other hand, is that exact same brain, but taken out of the jar, given a specific job to do, and handed a tool belt to actually execute that job. Moving right along to Section 2, anatomy of an AI worker. Now, when we translate this tech into human anatomy, it honestly clicks instantly. The brain is your model, say Opus 4.8 or Sonnet, which just reasons and decides. The hands are the tools, like read, edit, or bash commands, which let the AI actually act on the world. And the clipboard that the worker is holding, well, that's the prompt. It contains the job description and the standing orders. It tells the worker exactly what it owns and, just as importantly, what it is explicitly told not to touch. But hold on, because there's a really common trap people fall into right here. People often think the prompt is the body of the AI. It's totally not. The prompt is just the clipboard. The actual body and the nervous system, the literal infrastructure that wires the brain to the hands, that is called the harness. In environments like Claude Code, the harness is what carries the short-term memory and actually allows the worker to take action turn after turn. So, stepping out of our human metaphor and into the literal code for a second, this entire anatomical structure actually just lives inside a single markdown file. Think of the YAML front matter at the top of the file as the worker's DNA sequence. It just organizes everything in one convenient place. That's really it. Everything that makes up our digital human lives right inside this one genetic sequence. And you literally build this worker top to bottom in the code. It's pretty straightforward. First up, you designate the brain by setting the model. In this case, we're using Sonnet. Second, you grant access to the hands by defining the tool allow list, so things like read, edit, write, and bash. And third, you write out the explicit job description right in the body text. That's your prompt. In this specific example, our agent is named Software Dev Fixer, and its standing orders explicitly state that it owns JUnit tests, but it has a massive do not touch sign on Selenium suites. The DNA is perfectly sequenced. Okay, Section 3, skills and plugins explained. We hear these words all the time, so to cut through the confusion, let's categorize these modifiers simply. A skill is basically an operational playbook, and a plugin is just a shipping container. If you remember our physical worker analogy, neither of these things are the worker itself. They're just things that interact with the worker. To put them head to head, a skill is just specific guidance. It's a triggered instruction packet. Think of it as a playbook that only loads up when it's relevant. It is absolutely not a separate worker. A plugin, on the flip side, is the package that bundles the whole shebang together. It's the actual shipping box used to deliver and install the agent, its skills, and its tools right into your environment. So again, a plugin is just a delivery container, not a literal layer of the agent's brain or its body. Which brings us to Section 4, the proof, showing exactly why an agent does not equal a model. This right here is the ultimate proof. One central brain, the core reasoning engine, Opus version 4.8, can actively power two entirely different workers at the exact same time. The brain is literally just sitting in the middle, routing its raw cognitive power out to two totally distinct environments. Think of it like a tale of two completely different employees sharing one brain. Worker A is our software dev fixer. Its clipboard tells it to write code, and its tool belt has full access, including write and edit permissions. But then meet Worker B, a software security reviewer. Its clipboard orders it strictly to audit for vulnerabilities, and its tool belt is highly, highly restricted. It only has read and bash tools. It literally cannot write code. And this is exactly where the distinction becomes absolutely critical for your security. Because if you confuse a model with an agent, you might accidentally give a simple reviewer the hands and permissions of a full developer. Yikes, right? Even though they share the exact same reasoning engine, the exact same Opus 4.8 brain, they possess completely different job descriptions and completely different tool belts. And that is exactly why they are fundamentally distinct agents. All right, let's lock this in. We're going to review our 5 core definitions, distilled down into a single memorable line for each. The model? That's the brain, pure reasoning. The tool? That's what the brain is allowed to do, the hands. The agent is the configured worker. It's the brain, plus the job, and the tool belt. A skill is loaded guidance, your playbook. And a plugin is simply the shipping box. It's how you deliver it all. So, with the true anatomy of an AI worker now crystal clear, it leaves us with a pretty massive, exciting, and honestly formidable question. Look, we aren't just going to have one or two of these AI agents. We are going to have vast armies of them, all sharing massive cognitive engines. The models are going to provide the brains, sure, but it is entirely up to us to manage the clipboards and the tool belts. Because if we don't, whose fault is it when the wires cross? Thanks so much for joining me on this explainer, and I will catch you on the next one.